is Tobias Anel. I'm Innovation Project Manager at Ferrovial, and today in this presentation I will briefly present the case study number 5, which are the tunnels at M30 Ring Road in Madrid, Spain. First of all, I will present the infrastructure itself. The M30 orbital motorway circles the central districts of Madrid. It is 32.5 kilometers long. In its length and surface, it can be compared to the Boulevard Périphérique in Paris or the London Inner Ring Road. The M30 is the busiest Spanish road. It connects all the main Spanish radial national roads that all start in Madrid. And it can be noted that it includes several tunnels under the river Manzanares, which is a key aspect for the validation of the FORESEE tools. The aim of this use case was to implement and prove the advantages of real and accurate predictive maintenance strategies. The case is quite unique in several aspects, mainly for two reasons. First, it offers a big amount of heterogeneous data suitable for testing the hybrid data fusion approach. And on the other hand, it was the only FORESEE case study that analyzes direct anthropogenic hazard like the cyber attack. For this M30 case study, there were three parallel focuses. First of all, a cyber attack assessment, then a hybrid data assessment for diagnosis and prognosis tool, and last, a novel methodology for flooding events. In the next two slides, I'm going to focus on the cyber attack assessment. So a thorough analysis of cyber attack hazard has been performed in a case study of M30 highway based basically on three criteria. First of all, a socio-economical study, then a description of the scenarios that can be caused by a cyber attack on the M30 ring road control system, and at last, some recommendation and actions to be adopted were drawn. This deep analysis helps the infrastructure manager with the maintenance and operation activities in the case of a cyber attack affecting the highway. And now I'd like to present the hybrid data assessment package that has been tested in the M30 case study. So this hybrid data assessment tool encompasses a machine learning tool for diagnostic and prognostics of faults experienced by critical infrastructure in the face of an acting hazard. The HDA tools aim to support resilient decision for infrastructure assets when extreme events occur. The tool is termed hybrid due to its capacity to incorporate two sources of input, namely simulation models on one hand side, and on the other hand, actual monitoring data. Without entering in all the details, technical details of the research, the tool is based on two machine learning algorithms. First of all, Bayesian networks and random forests. In this case study number 5, the tool was tested in the framework of a cyber attack, and it works together with the traffic module that was developed and tested in other case study within the framework of FORESEE project. The main conclusions of this hybrid data assessment package is that once the model is trained with data derived information, it can help to predict the state of the system and to visualize the expected congestion under selection of a specific scenario of imposed flow restrictions. Basically, it can be considered that there are some inputs that are needed, for instance, traffic volume, closure time, flow speed at closure, location or nominal speed that is allowed, and the outputs are the effect on traffic, the decision on maximum allowed speed, the incremental travel times, and the possible impact on alternative routes. In the next couple of slides, I'm going to talk about the flooding methodology tool. First of all, present the area of study. As mentioned before, the case study is the M30 motorway in Madrid. But in the case of the flooding methodology testing, just a specific session was considered, which is shown on the map. It is basically a section located between the Puente de Toledo and the dam number 9. In the map on the right, you can see number 1 and number 2. This is the section that has been considered for the flooding methodology. Without entering into the specifics and details of the study, we would like to present a brief comparison between current tools and this new tool that has been developed. First of all, it can be said that that in the framework of the climate change, we will have increasingly frequent and more intense episodes. So that's the reason why infrastructure may overflow, and that will give rise to situation of collective risks. FORESEE flooding tool is a methodology that requires more computer resources and computational time, but at the same time it allows a more accurate design. We have a methodology that is stricter, which means that designing the infrastructure using this novel approach will lead to a more resilient infrastructure. This tool is useful during the design and construction phase, but it can be also used in management for management purposes, as it can give a thorough decision support if some reconstruction or elevation of the water defense is needed. And it can be, of course, stated that this is linked to a reduction of the maintenance costs in the case of flooding event. In order to close this presentation, I'd like to draw some conclusions based on the interest for the infrastructure manager and construction companies. First of all, these tools and the FORESEE project in general help us to understand the impact of major system disruption on the critical infrastructure and have dynamic resilient schemes based on data. The analysis of impact time, behavior of users, and evolution of alerts. And it helps as well to quantify the risks and costs associated with the impact of eventualities on infrastructure. All these tools and this study help to develop efficient action plans and tools for emergency, basically mitigation through decision support system that helps making agile decision in case of catastrophic events during the whole life cycle of infrastructure. It can also help improving awareness, response, and recovery time. And basically, more generally, it optimizes the way we design and build infrastructure in order to be more efficient and moving towards infrastructure that are safer and resilient and more resilient.